Today we're going to talk about the law of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed, it can only change forms. The example we gave of this was when kinetic energy changes into potential energy can change back to kinetic energy, and overall that's your mechanical energy. Like on a roller coaster, you start off at the top, not moving. You have 100 joules of potential energy and none of kinetic energy. Again, you're not moving. As you start to move, the amount of potential energy decreases because you're not as high anymore, but the amount of kinetic energy increases because you're starting to move more and more. Halfway, they are exactly equal. All the way at the bottom, you'll see you'll have 0 joules of potential energy because you're at the bottom. There's no further down that you can go. So you have 100 joules of kinetic energy because you were moving with everything you could. The energy does not get used up or disappear. Instead, the energy that seems like it might be gone has just been transferred into a form that's not helpful to you anymore. We'll tackle this when we talk about what happens when it's on the ground and not moving, where that energy went. Say you're back on this same roller coaster. You start off at the top, again, 100 joules of potential energy, 0 of kinetic. Remember, halfway you'd be at 50-50, and at the bottom, just before you stopped moving, you would have 100 joules of kinetic energy and 0 of potential. But where does that energy go? Because eventually that roller coaster car stops. Some of it would go to sound energy. That sound that you can hear, that's sound energy. Sometimes you can feel it. Imagine being at a parade when the bass drums go by. You can hear that, you can feel that in your chest. That's the sound energy moving through you. Or in a car with really loud bass, you can feel that sound energy. That's some of which is being released by the roller coaster because you can hear the roller coaster. The rest of that energy is going to thermal energy in the form of friction. It warms the track from the friction of the wheels on the roller coaster. So we have some more examples of other ways energy moved. Last year in life science, you learned all about food webs. This is a really basic one, pardon my awful drawings. The energy from there starts in the sun in the form of radiation, radiant energy, light energy, thermal energy. Obviously, the plants go through photosynthesis, and they convert this energy transfer, to be stored as chemical energy. The bunny rabbit would eat that plant, converting that stored energy from chemical energy, some back into restored chemical energy, some into kinetic energy for moving, a little bit into electrical energy for stimulating nerves and muscles, and some thermal energy for keeping warm, regulating body temperature, maintaining homeostasis. Again, now that bunny could be eaten by an eagle, that's an eagle, and the eagle would go through the same conversions. You see how some of that energy, it's not 100%, all chemical, all chemical, all chemical. As the bunnies use some of that energy for keeping warm, the eagle didn't need the bunny warm. So that energy gets less and less useful energy as it gets to the eagle. But the total energy in the system, if you count up the kinetic energy, the electrical energy, and the thermal energy, the total energy in the system remains the same. One last example is electricity in your home. An example of this is I drew the Hoover Dam. So it starts with a bunch of water, and that water rushes downward. The gravitational potential energy, that's gravity from the earth, is pulling that water down. That energy is then harnessed and transformed into electrical energy. That's LCEC. That electrical energy goes to your house. In that process, minimal electrical energy is transformed into thermal energy through a special kind of friction for electricity called resistance. When it gets to your house, your electrical appliances transform it into whatever kind of energy they need. For example, they could transform it back into thermal energy. Maybe it's the kinetic energy that moves the clock, or light sound energy for your television.